Hello, so what I'd like to do today is make a fractal tree. Now the code I've got on my screen at the moment is just the setup code to draw a box here that's 700 wide, 850 pixels tall, and it puts it in a specific location on my screen, so kind of it's, if I press play, it always starts over here, just so it's consistent. Now your mileage may vary with these numbers, but these work for me. But if you wanted to put it at a certain location, you might have to tweak these numbers a little bit. So what is a fractal tree? Well, if we jump in here and just diagram it, a fractal is a pattern that infinitely repeats. And so if we think about a tree, we have a trunk of that tree, and then we have a branch on that tree. Okay, so this tree is going to have two branches. And the way a branch is defined, when we're talking fractally as a tree, obviously in nature it does stop, but when we're talking fractally, a branch is defined as having a branch element and it has two branches on the end of it. Okay, so every time I draw a branch, I have to draw two branches on the end of that branch. So two branches. Now these branches should get smaller and smaller, so I'm going to try and keep it at a reasonable length. Okay, so now I've drawn these four branches, I need to draw branches on the end of those because each branch should have two smaller branches on it. So now I'll draw two branches like that. Okay, and now these 8 branches, they all need to have branches on the ends of those. So now we can draw branches on the ends of these. And now these 16 branches, once I've drawn them all, we'll need branches on the end of them. And you can see how this will just keep going and going and going into infinity. Now, in your imagination, this is fine. And in kind of in an animation where we can make things bigger and zoom in, then that's absolutely fine. But for the purposes of kind of pixels and working on a computer, there's going to be a point where we just cannot draw any more of these branches. And so there's going to be an end condition when a branch gets so small, like this small, maybe we're going to say actually that's when you don't have to add any more branches to the end of your branches. And we can have a little play around with that. So what we're going to do is we're going to look at how we can use a programming technique called recursion in order to draw these branches. And recursion is when you have a function that calls itself. And we're going to look at that now in the code. So let's get our draw loop in. So void draw. And we are going to put in a background of white. So let's do 255. And now what we need to do is we need to make a new file, and in that I'm going to make my tree class. Okay, so the class that's going to manage my tree. So my new name for my file is tree. Maybe I'll put a capital letter there because it's a class. Tree, and we're going to say class tree. So we can make new trees, and whenever I make a new tree, I'm going to give it, what should I give it? I'll probably give it some starting coordinates. So I'm going to give it a start x, that's going to be a floating point number, and a start y. We'll have a p vector for position. So a p vector is just a data type that processing has added for you that allows you to store an x and a y position, and it's really helpful. So p vector pos for position, and we'll say pos equals a new p vector with start x and start y. So that's our, oh, it should be this.pos. This.pos equals new p vector with start x and start y. So whatever we give it, that's where it will start. So that's the start position of our tree. And now I'm going to write a method or a function. If a function's written inside a class, it should be called a method. So, but it's still a function. I guess it's a procedure because we're not going to return anything. But anyway, we're going to call it generate branches. And this is where we're going to do all of the recursion. And so in here, we are going to call generate branches. So when we make a new tree, we're going to give the position. We're going to give that a start and a x value and a start y value that we pass into the tree when we make it. And then we're going to generate our branches, okay? And the functionality for generating branches is down here. Now the first branch we're going to generate is going to be our kind of root, our trunk, if you like, okay? So I'm going to make a data type called a branch, and I'm going to call the first one trunk because that's our beginning one, and that's going to be equal to a new branch. Okay, so let's make the branch. So we've got a tree, let's make a branch. And a branch is going to be very similar to a tree. So actually I'm going to copy all of this. I'm going to paste it there, and I'm going to change this to class branch, pvector pos, branch. When we make a new branch, I want to give a start position. Yep. Yeah, let's have a think about that. So when I create a new branch, really everything I need to know is inside my parent. So if we're talking about this branch here, let me put this in a different color. If we're talking about the trunk here, okay. Now, when I make this trunk and then make a new branch on top of it, I need to know where this end position is. So I need to, let's just drop this down a little bit. I need to know this here will be my branch's end position. This will be my start position when I draw this line. But for this branch here, this will be my start position, and this will be my end position. And so what I need to do is I need to know what my parent, let's call it a parent, my parent's branch, what that was, so that I can then kind of calculate my own position. So what we're going to do is we're going to expect whenever we create a new branch, we're going to expect to be given our parent as an argument, and that parent will just be another branch. Now the first branch that we make, the trunk, it won't have a parent, and so we also, let's data type of branch, we also need to make another branch. So when I create a branch, I either give it a branch argument and I do something, or I give it a start x, a start y, and we draw just a single branch to begin with. So let's try this out. So let's just get our trunk working. So in our tree, we need to have an array list of branches that stores all of our branches. Array list branch branches equals new array list branch. Okay, so we've got ourselves an array list. Now, when we get our trunk, we're going to say this.branches.add, and we're going to add our trunk to the list. And then we're going to display our branches, so void display, we're going to say for branch b in, the colon stands for in this dot branches, let's say branch dot display, and in our branch here we need to write a display function, void display, and we can do that in a second. And in our tree we just need to put in, sorry, in our main code we need to put in our tree. So I'm going to say tree equals, oh no, tree in setup we're going to make a new tree. Processing prefers us to make new objects in setup or draw. So let's do tree equals new tree, and we're going to give it the start position of width over 2. So however wide the canvas is, and then height, so right at the bottom so we can draw it upwards. Okay, cool. So tree equals new tree, and then we're going to come down here and say tree.display. And so that should be all the code we need to put in here, and the rest will all happen in branch and tree. So when we make a new tree, we pass it this start x and start y. That's saved in this .pos, and then we generate branches. Our generate branches is making a trunk with a new branch, and our new branch is going to use this .pos .x and this .pos .y. So this here, we're given the start x, and in here we told it start x is width divided by 2, which is the middle of the screen, the center, and the start y is height, which is all the way at the bottom here. So we'll start in the middle. And so we have our tree's position. We generate branches. Our trunk is a new branch at those positions we just given in, and we then add that trunk to this .branches. And then for every branch in this .branches, which at the moment is just one that we've added, okay, we're going to display those branches. So down here, I need to say we're going to draw a line, and it's going to be from this .pos, this .pos.x, this .pos.y. Probably need a start pos and an end pos really. So let's do start pos and let's do end pos. So we're going to say, if we just pass this, we're going to say this.pos equals new p vector start x and start y. So this dot start pos, and so this is the constructor we'll use if we are just making the trunk. If we pass in two floats when we make a branch, if we pass in two float values, it will do this code. If we pass in a branch instead, it will do this code. Okay, and they're going to be slightly different. This is from the tree, so we can get rid of that. Let's comment that out for now. So this.startPos equals a new p vector start x start y. And now what we need to do is calculate our end position. So what I would like to do is maybe make a constant up here. So float start height, and when I add in start x, start y, I'm also going to add in float start height. No, hang on, no. When I pass in start y and start down here, I'm getting lost now. Okay, float start height, we're going to set that equal to 100. Okay, and then we're going to say down here, when we make a new branch, we're not just going to give it an x and a y position, but we're also going to give it its starting height. So this dot start height, and that will be our starting height for our tree. So we are going to say this dot end pos equals new p vector. Our x position is going to stay the same. So here in our tree, our x, all that's doing is our y position is changing as we go up for our trunk. So this dot end pos equals start x and start y add, and we need to update this with our, what was it? Start height. Let's just put height. Nope, that's a reserved word. Let's just do h. Add h. So new p vector, start x, start y, add h. And now when we draw a line, we can draw it at this dot start pos dot x, this dot start pos dot y. So they are our x and y coordinates for where we start. And then we're going to draw it at this dot end pos dot x and this dot end pos dot y. And that will hopefully, no, missing semicolons as always, semicolon there. Any more for any more? That will hopefully, can't find it, oh, I did branch.display, I called my variable b, so I have to use b.display. Okay, and instead of adding h, I need to minus h because 0 is up here in the height, and then the full height of 850, I think it is down here. So I need to be minusing height, and now hopefully I've drawn a line. Fantastic! Look how much code we've written. We've written what? 18 lines of code here. We've written 20 lines of code here. We've written 12 lines of code here. So we've written about 40 or 50 lines of code, and we have drawn a line. Fantastic. Okay, so now what we need to do is we need to start adding more branches. Now, when we add a branch, what we want to do is add another branch. So I'm going to make a new function called generate branch singular. And this is going to call itself. So it's going to say this dot generate branch. And we're going to say, we're going to pass in the parent. So whoever this new branch should be connected to, and we're going to say if this dot parent, let's create a length. So let's say float length. Oh, can you see that's highlighted? I just call it len. Float len equals float len, and then in here we're going to say this dot len equals h, and so that will be our length of our branch. And then when we make one with just a parent, we're going to say this dot len equals parent dot len multiplied by, let's create a float up here, and let's call it something like modifier, and we can set that equal to 0.67. So then we can just change it in one place. So I'm gonna that's gonna be a constant actually, modifier. So I'm gonna say parent.len times this dot modifier, and that will reduce our length of our branches as we go down. Okay, so if this dot parent dot length is less than, let's say 10, no, let's say greater than 10, sorry, it's greater than 10, then we want to generate a new branch. Otherwise, we want to just stop, because we don't want to keep generating once we've gone lower than a certain number, because we're just not going to see that detail. This screen is 850 pixels. You can't see half a pixel. You can only deal in whole pixels. So we could go down as far as 1. We can change this number. In fact, let's make a constant called threshold. Let's say float size threshold equals 10, and then down here we can say it is greater than this dot size threshold, and so it's quite easy to change up here. So I'm trying to, anything that I think I might be able to change once this is up and running, to make it interesting, I'm going to kind of set up here so that it's easy for me to tweak rather than diving into the code. So my generate branches is going to add a trunk, and then what I'm going to do is I'm going to say generate branch, and I'm going to pass in that trunk. So that trunk will be the parent for the next 2 branches. Okay, so my generate branches function makes a trunk, adds that trunk to my list, and then it generates a branch for that trunk. Now generate branch will generate a new branch, and what I need to do is I need to give it a direction. So I need to say, what do I need to give it? generate branch. So this dot generate branch. Okay, so I need to do two that generate branches because I need to do one that goes off this way, and I need to do one that goes off this way. Okay, so I'm going to generate two branches. Let's do that. Yep. So generate branch. If this dot parent dot len is less than size dot threshold, then we are going to say branch b equals new branch. We're going to give it our parent, which is parent. So we're passing in the parent here. We're going to make our new branch, our new kind of child branch, if you like. Let's call this new branch, just so it stays. So we retain some kind of sanity, equals new branch. We're going to then say this dot branches dot add, and we're going to add in that new branch. And then we're going to generate a branch using this new branch as the parent. And so this new branch gets passed into parent. We check this new branch's length, and then we make a new branch, a new branch, using the new branch parent. And then you can see this kind of recursively will go round and round and round and round and round until this if doesn't allow it to go any further. Okay, so what we need to do now is think about what angle they are at. And so for that to happen, we need to give it a certain amount of degrees of rotation. So I'm going to say, let's set another float up here. So yeah, I set them as floats, and I always use integers, but this allows me to fine tune it later on. So I'm putting it on as float as a kind of long-term thing, and then that allows me to be flexible with these. So I'm going to say float angle equals, and let's just say kind of 40 for now. And then I'm going to pass in this dot angle, and I'm going to pass in this dot minus, this dot angle, but I'm going to put minus at the front of that one. So it draws one at minus angle. Okay, so now I need to do the same idea, but down here. So I'm going to say branch new branch equals new branch parent, and this dot angle, this dot branch dot add, generate new branch, and then I'm going to copy this and I'm going to paste this down here, but instead I'm going to use minus this angle, and so this will generate a branch that points out in this direction, and then it will recursively call itself, and it will generate a branch that pulls out in this direction, and then this direction, and then this, and this, and it will kind of recursively kind of complete, and it will be amazing. And then the second one, this one here, will deal with this branch here, and this branch will poke out, and then it will call two more branches. And so every time I call generate branch, I tell it to generate two branches. So I call generate branch here, it generates two branches. I then call generate branch on this branch, and I create two branches, and I call generate branch on this branch and create two branches, and we start getting this really interesting recursive stack where I am doing something very complicated with not a lot of code, which is pretty interesting. So so I'm going to say, I'm going to maybe call this left branch. Let's change that, left and left, and I'm going to call this right branch, just to make it really clear. Okay, so now what we need to do is just get the branches to draw themselves at the right angle. So when we make a branch here, we calculate our length, and now what we need to do is we need to actually work out our start and end coordinates. So our start coordinates are going to be our parent's end coordinates. So we're going to say this dot start pos equals new p vector, and it's going to be this. No, it's not. It's going to be parent dot start dot end pos dot x and parent dot end pos dot y. So that's going to be where we start. Now, what I want to do is I want to take my parent's branch, I want to shrink it a little bit, and I want to rotate it. And so what I need to do is I need to do some vector math. So I'm going to say p vector dot subtract, and I'm going to take away my end position from my start position. So I'm going to say this dot position, sorry, parent dot pos, and I'm going to take that, oh, sorry, parent dot end pos, and I'm going to subtract that from parent dot start pos, and that will give me a vector. So I'm going to say p vector, let's call this, what are we working out here? Direction, I guess, equals that. We're then going to say we're then going to say p vector dot add. What are we going to add? P vector dot add direction. We're going to multiply that by our modifier. And then what are we going to do? We want to take this and we want to put it up here. So we need to rotate it. P vector dot rotate direction. P vector, no, I need to do direction dot mult. And I think we're passing in a direction, aren't we? And I need to call radians on this, because the rotate takes a amount of radians rather than degrees, and so you need to convert degrees to radians. Okay, so we've done that, and then what we're going to do is we're going to say this dot end position is equal to direction. This needs to be direction dot rotate stop end position. Okay, does anything happen now? No semicolon, no semicolon. Sort it out, no semicolon. Okay, let's have a look. No semicolon. No semicolon. This is just embarrassing now, isn't it? Duplicate local variable direction. Oh, I see. I've passed in a direction here. Let's call this angle. So we're going to rotate by angle. This is a constant, I think, so this should be uppercase. Oh dear, what's going on? Float angle, trunk, distant angle, it is a float. The method generate branch in the type fractal tree.tree is not applicable for the arguments fractal.tree. Oh, I see. I don't need to pass this into generate branch at all. I just need to use it down here when I make the branch. So I can get rid of that. Okay. The parent cannot be resolved, so it's not this dot parent, it's just parent. Okay, we've done something, but it does not look great right now. And I think that's because my vector math is a little bit off. Okay, so instead of saying, I can't say this dot npos equals direction, I need to say this dot npos equals p vector dot add my direction to my start pos. And so I've taken my, I've created a new vector. I've subtracted my parent's n from my start, so I've just got a kind of a description of this line, okay? I'm then making it smaller, I'm rotating it, and then finally I'm adding it to this point here so that it is now pointing like that. And so hopefully now when I hit play, look at this. Look at this, okay? How close to that diagram is this? Amazing. Okay, so what have we got here? So we've got a few variables up here. We've got a modifier which tells us how small the branches should get each time. We've got a start position, an end position, and a length of our branches. Okay, and we manage those in these two. Here, this first one is for if we make a trunk of a branch. So if the branch is actually the beginning branch. And the second one here is for all subsequent branches. So it can take its parent and it can work out where it should be drawing itself. Okay, now we can start to do something really interesting. So in the tree here, we're doing something very simple. When we make our tree, we are giving it a position that the tree should start in with a start x and a start y position, and we're saving that in a vector. We then call the generate branches function. The generate branches function creates us a trunk at our position that we've just stored here in this .pos, this .pos.x, this .pos.y, and we also have a starting height of our tree. We then add that to our list of branches, add that trunk, and then we generate two branches using the trunk as the parent. Okay, and those two branches, when we call generate branch, they not only create a one new branch, but they create two branches of their own. So they add a branch from the left and a branch from the right. In fact, wait, could I get rid of this? Yeah, I did not need that twice. Okay, so when I call generate branch, I give it the parent of the parent, which is the trunk to begin with, and then I can call generate branch. So my parent is the trunk, and if my parent.length is greater than this .size threshold, well, my start height is 100, so that is definitely greater than 10. So I make a left branch, which is a new branch, and I add that branch to my branches. And then I call generate branch. So then left branch becomes the parent. It checks its length against the size threshold. It then makes a new left branch, and then it calls itself again, and it keeps doing that until its length, until we get down here and its length is greater than this, until it's not greater than the size threshold, and then we come back all the way to the back and then start making the right branches. And this essentially allows us to make loads and loads of lines without having to write loads and loads of code. Obviously, we've written a fair bit of code, but nowhere near as much as if we were to write all of these lines out one after the other. So now we can start to kind of tweak this. So my start height, let's make it 200 and see what that does. Cool, so it's just made it bigger, fair enough. Let's make the size threshold 1 and see what that does. Ooh, okay, look at that. Cool. Let's change our angle. Instead of 40, maybe let's do 90 degrees. Whoa. Wow. Okay, let's do maybe 20. Look at that. So you can see how we can just change these variables and we can get some really complex patterns and some really different patterns coming out from this algorithm that we've written. Our branch here has a modifier of 0.67. What if I change that to 0.9? Ooh. Okay, I think that's having to make a lot of branches. Maybe let's drop that down. to 0.7. No, let's do 0.8. It might have crashed. Okay, let's try that again with 0.8. I'm sorry, processing. Okay, it's not liking that either. Okay, let's try like 0.75. Stop. Wow. It okay. Oh, wow. Okay, cool. So you can see that it gets so dense in the top there that we just lose a lot of detail. And so actually making these longer, so this modifier is changing how short the new branch is. Okay, so this is 75% of the height of this one, these two children, and these two children are 75% of this one. But you can see when we get down to the micro level, we're actually losing a lot of detail because it's so clustered there. So actually, what if I was to do like 0.5? Okay, so we got a very small set of branches. What if we did, let's say 0.6? Yeah, so you can see it's kind of becoming more tree-like, and then 0.67 I think is quite a sweet spot really for this. So now let's start thinking about how we can make this maybe a bit more interactive and take advantage of processing's kind of animation features. So in Draw, what I'd like to do is well, no, not in Draw. I'd like to use the function mouse pressed. And this is code that's executed. It's built into processing, mouse pressed. This is anytime the mouse is pressed, I want something to happen. So I could just say print line, oh, pressed. And if I run that, of course, I forgot my semicolon. If I run that, I can click in here, and you can see down here it's outputting pressed. Okay, so we can see that every time I click, it's saying pressed. But instead of doing that, let's do something more interesting. So let's create a variable called, what should we call it? Let's call it angle. So let's say float angle, and let's say angle is equal to 0. And when the mouse is pressed, we're going to say angle plus equals 1. And then we're going to, when we make a new tree, what we're going to do is instead of setting the angle here, we're going to pass in the angle. So I'm going to pass in a float angle, and I'm going to say this dot angle equals angle. And now, when I press the mouse, I'm going to say tree equals new tree. Same width over 2 and height, but this time with a different angle. I don't know why I've done this in capitals, because it's going to definitely change. So I'm going to say that angle is going to add 1 onto itself by using plus equals, add 1 onto yourself, and then our tree, we're going to make a new tree. We're going to overwrite this tree variable with in the same position, but we're just going to change the angle. So now if I hit play, what haven't I done? I've not put a semicolon in. When I hit play, okay, you can see that with 0 degrees, we just get a straight line. But if I click the mouse, that should increase the angle by 1. And if I click it again, and if I keep clicking, you can see that we are slowly changing that angle. And in fact, let's do something a bit more. Let's put a text in at the top. So let's say text angle, and let's put it at, I don't know, 10 width and 10 height. So that should be in this corner. Maybe not. Let's do text size 20, and let's draw this at maybe 30 and 30. Have I done that right? Ah, I can't draw text. Why can't I draw text? Fill. It's probably there we go. Okay, so we've got our text there. So now if I press the mouse, you can see that's 1. I've kind of made this, let's make this an integer, just to make it easier. Cool, and let's do angle plus the string of our integer angle. Cool. So now every time I click the mouse, you can see that that is updating. Now, one thing I do want to make sure is that when I go above 360, it kind of reverses. So I would like to maybe make an int called increment. And we're going to increment by 1, and then angle plus equals increment. And then we're going to say if angle is less than 0, or with a double pipe, or angle is greater than 360, we're going to say our increment is equal to our increment times, so times equals increment minus 1. Because if I multiply a positive number by a minus number, it becomes minus, and if I multiply a minus number by a minus number, it becomes positive. So I can change that increment to start taking away from angle or start adding to angle. And so then it will always kind of loop. So if I hit play now, we should be able to click, and we can keep generating new trees and start looking at kind of what would be a good, nice angle for us. So look at that. That's kind of really, that's getting really interesting. So that's 45 degrees. That's pretty cool. I really like 90 degrees. I think that's, this whole like square thing is really cool. Now this is going to just start like folding in on itself now, which is kind of interesting. So the more obtuse our angle gets, the odder this gets. So you can see it's kind of like forming like these little weird triangles now. It's a very interesting pattern. It's so condensed as well. Everything's really kind of turning into kind of almost solid shapes rather than just lines. So remember, this is just a collection of lines, but the way they're being drawn, it's almost like they're kind of filled in shapes. So we're at 135 degrees now, and we've got a pretty interesting tree shape there. And let's just see if we can get all the way to 360. So it is just like being consumed by itself now. It's going into like a black hole. And that's 180 degrees. We are just, everything's in a straight line, and then we're going to pop out the other side, and we're just going to see a reverse of that process. Now what I could do is, instead of having this in mouse pressed, I could put this into draw, and so that would animate for us automatically. So let's do that. Let's pop this down here. In fact, what I want to do, instead of duplicating code, I'm going to say void animate tree, and then I'm going to say, I'm going to allow myself to use the mouse press, so void mouse pressed. I'm going to just say animate tree there, and I'm also going to animate tree in draw. So every time, this draw loop runs at 60 times a second, okay? Every time it comes down here, it's going to do all of this code in animate tree. So now when I hit play, look at that. We've got this really cool fractal pattern that is just changing. Kind of folding up on itself and then kind of blooming out of the other side, I guess, in a second. Now, it is running fairly slowly. It's having to make all of these branches again and again and again and again and again. It's not a very efficient way to do this. I could probably make the tree once and then start editing the actual rotation of the branches and be a lot clever about it. But as a kind of quick hack, this works quite nicely, and it gets us to see these different types of tree that we can produce. Now, what I'm going to do actually is void mouse pressed. I'm just going to say no loop so that I can pause my animation. So if I get to a nice angle like here, I can click my mouse and it stops my draw loop. And so here I have the tree that I want. Unfortunately, it won't actually start it again, but that's okay. So that has been Fractal Trees. I recommend that you play around with the like the thresholds, start height, the modifier, and see if you can create something that maybe animates in a more interesting way. So for instance, what could we do? We could do instead of changing the angle, let's leave the angle at something like, let's pick a good angle. Oh, no, didn't want to click that soon. Let's pick a better angle than that. So yeah, let's say somewhere around 35. So let's put in our trees angle at 35. I'm just going to stop that animation. And what we're going to do instead is we're going to pass in the start height. So I'm going to say start, I'm just going to call it h. So this dot start height. So instead of this dot angle, we can say this dot start height equals h. We're hard coding our angle in, and this time we're going to, actually I could just leave this at 200 and then just overwrite it down here. That seems like a much better thing to do, because then I can just whip these out and it will still work. So this dot start height, I'm going to overwrite it and set it to h. And now what I can do is every time I pass this in, instead of it being an angle, it's going to be the height of the tree. So let's just rename these quickly to H, 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 and H. And instead of being greater than 360, let's do it. No, let's keep it at 360, see what happens. So let's see what happens. So instead of changing the angle this time, I'm going to change the height of the tree. So it's going to start at 0 and it's going to work its way up. And let's just make a height here. And so this doesn't like something. Angle cannot be resolved to a variable. That's because I need to put h. Let's go. H plus equals increment. I really thought I got rid of all the angles, but I did not. Look at this. It is growing before our very eyes. How cool is that? Now imagine if you got the height going with the angle as well, so it kind of was opening up as it was growing bigger. So let's do that as well. So instead of this dot start height dot h, let's do this dot angle equals h as well. So not only is it starting really small, it's going to start closed up, and then it's going to start branching out as it grows. So now, oh. Okay, my laptop does not like rendering this. This is really performance, like it's not enhanced at all. It's really performance heavy. It's a very stupid way to have written this. Now, my angle is maybe a bit too much. It's a bit too fast. I think what I'm going to do is I'm going to say equals h divided by 10. So it's going to be 1/10 of the height. Oh yeah, that's the stuff. Look at that. Look at this tree growing. That is amazing. That's really cool. So you can see that I've just made some little changes and I've been able to animate this. I've been able to play around with how it behaves and change how it looks and start getting some really interesting things. Now, this is going to get to a certain size where I'm just not going to be able to see it. So maybe, maybe 360 is just a little bit too big because I've just got a nice big stick on my screen and not much branch. That didn't make any sense, but yeah. Maybe it's probably going to shrink now though. Yes, look, it's gonna start shrinking now because our increment has been times by -1, and so it is now h is adding a minus number rather than a -1 rather than a positive one, and so it's going down by -1 each time. Okay, have a play around with this and enjoy, and I will see you in the next video. Sayonara.